Okay, welcome to lesson number 4, absolute value functions and reciprocal functions. So today we're going to look at absolute value transformations. Now, this is actually going to be one of the easier lessons that you're going to do. The first thing we need to consider is a function where y is equal to f of x and y is equal to the absolute value of f of x. So, the function we're looking at has the equation of y is equal to x minus 1. So the first thing we need to do is write the equation for y is of the absolute value of f of x. So if we know that f of x is equal to this equation x minus 1, then the y of f of x is going to be equal to y is equal to the absolute value of f of x, which is x minus 1. So the absolute value of x minus 1. Part B is we need to complete this table of values in the right-hand column over here for y is equal to f of x. So this part of our equation, and also for our absolute value equation of y is equal to absolute value of x minus 1, or y is equal to the absolute value of f of x. So basically all we're doing is substituting our values of x into our equation. So if I were to substitute my value of x into this equation of y is equal to x minus 1, this is going to become y is equal to negative 4 minus 1, or y is equal to negative 5. Okay, and you'll find that as you insert each of these values, your value of y is going to increase. Okay, so rather than writing each one out, I'm just going to take a shortcut and write down what the value would be if I inputted each of these values of x into my original equation. Now, remember, if I were to do this in my absolute value, whenever my value of y was negative, because I'm taking the absolute value, it's going to be the same thing, but we're going to have a positive value. So for example, if I had y was equal to the absolute value of x minus 1, that's going to become y is equal to the absolute value of negative 4 minus 1, or the absolute value of negative 5, which would equal 5. So the same thing's going to happen, and we will follow the trend that happened here, but we're going to decrease, and then we are going to increase again. Okay, so sketch the graphs of both of these functions on the same grid over here. So let's start with this graph of y is equal to f of x, or x minus 1. So I'm at negative 4 and negative 5, negative 3 and negative 4, and we are going to follow a trend like this, and we're going to continue going up. Now for y of the absolute value of f of x, I was at negative 4 and positive 5, negative 3 and 4, and I'm just going to follow the opposite trend. And sorry, I shouldn't have gone down here because it goes up here and then up. So I just got a little carried away there. And so ignore these points because they don't actually exist. Okay? Now complete the following statements based on our observations in C, where we sketched our graph. So if we were to look at this graph and recall that this is y is equal to x minus 1, and this here would be y is equal to absolute value of x minus 1. When f of x is greater than or equal to 0, the graph of y equals absolute value of f of x is actually the same as the graph of y equals f of x. So it's actually identical but it's only identical when f of x is greater than or equal to 0. So right here was when this graph of y equals x minus 1 was the same. Okay? When f of x is less than 0, the graph of y equals absolute value of f of x, so this part up here, is actually what it is a reflection in the x-axis. Is a reflection in the x-axis. Okay, so basically, when we had any data points less than 0 for my y values, then they were transferred across my x-axis, reflected across my x-axis into my positive y-axis up here, into quadrant 2. So basically, it's hitting where it hits the x-axis, it's reflected up in this direction. So number 2, the graph of the function f of x with equation y equals x squared minus 4 is shown. So write the equation for y is equal to f of x, absolute value f of x. So this is my f of x. So all I need to do is substitute that into my absolute value equation. So that's going to become the absolute value of x squared minus 4. And then they want us to use the graphing calculator to sketch this graph. Okay, so we'll turn that on, clear that, and put in our absolute value bars. So remember, you go to math, your math function, and then you need to choose option 1, and that's going to be x squared minus 4. Close that bracket, and then graph. So you have that W that's forming. So what that looks like, let's find out exactly where that is. I'm going to zoom in so it's standard size, and so that looks like that is crossing at y equals 4. So right here, and it's doing something like this. So basically, do the observations from number 1D, do these same observations here apply to this example? Well, let's see. This is saying when f of x was greater than or equal to 0, the graph of y is identical to the graph of y equals f of x. So this is my absolute value graph right here, and this here is my y equals x squared minus 4. Now, when f of x was greater than or equal to 0, the graph was identical, right? Like these points are exactly the same when it's above 0. But when it's less than 0, so down here, these are all negative numbers, then there's actually a reflection again in the x-axis. So yes, the same observations apply in this case. Now let's see. So in general, this is an important part to read. In general, given the function y equals f of x and the graph of y equals the absolute value of f of x, you're going to find the following characteristics. And that's what we found previously. So when f of x was greater than or equal to 0, the graph of y is equal to absolute value of f of x is identical. But when f of x is less than 0, then the graph of the absolute value is going to be a reflection across the x-axis. So, following those rules, in each of these cases, we have the graph of f of y equals f of x shown, and we want to sketch the graph of y equals f of x. So, we know that anytime our y values are above 0, greater than or equal to 0, that it's going to be identical. So, this graph is going to look like this, but anytime we have values less than 0, we're going to have a reflection in our x-axis, so the absolute value of this graph would look something like this. All right, and that's all there is to it, really. And the same thing over here, anything below 0 on my y-axis is going to be reflected across the x-axis here up top. And so if we're at -1, we're going to have now a minimum point of +1, and everything's going to open up into a positive direction. So this would be the absolute value function right here. So this is y is equal to absolute value f of x, and same with, let me just highlight this one so it's a little easier to see. And this is also y is equal to the absolute value function of f of x. Okay, so consider the graph of y equals f of x and y equals opposite value f of x from parts 1 to 3 of the investigation. So let's just look at these first graphs here. In both these cases, if we were to examine the domain of y equals f of x and the domain of y equals f of x, so the absolute value function of f of x and y equals f of x, we're going to find that they all have the same domain. So all of our values for our x axis are going to remain the same. So the domain is the same. But if we look at the range did change, right? Because the range has to do with our values of y. So the range of y is equal to the absolute value function includes the values of our regular function f of x only though when f of x is greater than 0. And all the values of the negative f of x when our f of x was less than 0. Again, the x-intercept remained the same, and the y-intercept, if the y-intercept was positive, then everything was the same. So if it's positive, it remains the same. Oh, sorry, go down a bit. If it's positive, it remains the same, but if it was negative, then remember that there's going to be a reflection into the opposite axis. Or there's going to be a reflection into the x-axis, or it'll be opposite. If it's negative, the y-intercept is the opposite value. And there you have it. That is lesson number 4.